So, hello everyone. In case you've forgotten from this morning, I'm Martin Robinson, and I want to talk a little bit about something we've been working on at Igalia, which is implementing native accessibility support for Chromium on Linux. And as I was thinking about this talk, I was thinking there are a lot of really detailed things about this work that are probably not interesting to anyone at all except people working on it. So I thought I'd give a more basic introductory talk, which I'm sure this will be old material for a lot of you, but I thought it might be more interesting to a wider audience than nitpicky details about desktop Linux stuff. But essentially, I just want to talk a little bit about what it's like to implement accessibility in a web browser, which is basically the bit that connects all of the accessibility code in the web browser to the platform APIs. And also to kind of explain, I think sometimes as web implementers, if we're not familiar with the accessibility code, we run into it because it's something is slow or it's crashing, and we don't really know why it's doing that. So I thought maybe this talk might help a little bit to understand a bit more why these kind of issues come up. But to begin, I thought it might be interesting, although I'm sure it's not necessary, to motivate a bit accessibility, because maybe a lot of us hadn't had a chance to think very deeply about it. So essentially, why accessibility? And I think the first and most obvious thing is that more and more the web is like a public space that we all have to use to interact in daily life. And the idea that some people would be excluded from the web is just unjust to think about that. And I'm sure maybe some of you have had a little bit of what this experience is like if you, for instance, join a new group. There's a bit of an echo, but I think it's fine if I talk a bit more quietly. Join a new group and they only announce their events on a certain social network that you're not a part of. That's an example of what it's like to be excluded, a very small slice. Or maybe in your life you've used the web to avoid, even if there's an alternative, the web is just way more convenient to use. Maybe you can avoid standing in long queues at bureaucratic offices, or even get food more quickly. And the idea that somehow people with a different set of abilities can't use these shortcuts or these frankly convenient ways of doing things is just obviously unjust. So I think this is the most obvious reason why accessibility is important. But if you're still not convinced, you should know that accessibility is useful for everybody. It's not just the people that you imagine in your head when you think about accessibility. For instance, maybe you use accessibility affordances without thinking about them, or they make your life easier in ways that you don't think about. So, I'm sure, raise your hand how many people have had luggage that has wheels that you pull, or have pushed a baby carriage. I think that's everyone. I'm sure you've seen one of these things. This is a curb cut. Essentially, it's a ramp that lets you go up onto the sidewalk. These are so common now we don't think about them. But really, these didn't exist, except for a few specific places until the 60s or the 70s. And still there are some places that are adding them. And this is something that makes our life easier every day. We don't think about it anymore. And we have disability advocates in the 1960s to thank for this, because in Berkeley they went around with sledgehammers and added these on their own. And now they're everywhere and everyone loves them. So this is known as the curb cut effect. Basically the idea that these affordances can offer things to everyone. In addition, there's a really famous graphic from that Microsoft produced, which I've included here, which explains this idea that not even things that are permanent, but also things that are temporary, or even in just like a particular situation, can lead us to being excluded. For instance, if you've broken your arm, maybe you can't use things that require two hands, or if you're holding a baby. I mean, these are the kind of situations where having accessibility technology can be really helpful. Another example is if you speak a variety of English like me, and you have difficulty understanding other accents, closed captioning can be very helpful. I mean, these are things that we use every day that we don't think about, but really they started out as accessibility technologies. And if none of that convinces you, then you should know that accessibility more and more is the law. And maybe you saw this. This is a few days old. Basically, the U.S. Supreme Court said that that Dominos Pizza could not avoid being sued for having an inaccessible website. So basically, if you produce web content, more and more, if that content is not accessible, you could be liable for large fines, or whatever. So money is a big motivator. So if the other things didn't convince you, I'm sure this will. So anyway, that's just an introduction to kind of motivate why this is important. So it's really big here. So when we're talking about web browsers, what kind of assistive technologies are we talking about? There's just like a list of some common things. Probably the most common thing that we think about is a screen reader, which is just software that takes the text of a web page and reads it, or maybe describes the content a bit. And if you have at least if you have Linux or a Mac, you should have a built-in screen reader. You could turn it on in your settings and hear what it's like to use one. But there are other things like Braille displays that can produce Braille, or on-screen keyboards, magnifiers, and debug inspectors, which is an assistive technology that people implementing accessibility use to make sure everything is working. And just a very quick overview of what the architecture of this looks like. Typically, on one side you have your web browser, and almost always there's a process boundary, and some accessibility APIs that span that process boundary and interact with the assistive technology. And the arrows point in both directions because there are queries that can be made, or commands that can be made from the assistive technology to the web browser, and there's also a command flow, or information flow, like to the assistive technology. So it's a two-way thing. And inside the web browser, typically what you have is you have the layout tree or the flow tree, whatever you call it in your browser. And then, typically speaking, there's another tree, which is the accessibility tree, which is a transformation of the layout tree into a tree that's useful for interacting with accessibility, assistive technologies. And typically what happens is this accessibility tree is hooked in some way to the platform accessibility APIs. So this is all well and good, but what does this look like? Essentially, when we think about the data flow going from the assistive technology to the web browser, the kind of things that the assistive technology might be asking about are the structure of the tree. What are the parents? What are the children? What is the relationship between the different objects? And these would be objects on the page. Divs. The mapping is not one-to-one, but it's got a very similar shape. Also, the dimensions of the objects on the page, which means that obviously it also includes maybe information from the painting phase, or it's not exactly just the layout tree. And their positions. Also this idea of the role of accessibility objects, which sort of, there's this conceptual issue when we're dealing with assistive technology where the technology really wants to know, like, not just what the thing is, but why it's there, which makes it easier for the technology to interact with that and explain it to the user of the assistive technology. And this role goes toward answering that question. It doesn't always answer the question, but it's useful. And the web browser typically has a mapping from different page objects to different roles. I'm explicitly not talking about ARIA here, but that also hooks into this and adds information to this as well. Other things are properties of node, font, color of the text, all these kind of things. And the text content of the node, which is obviously useful for a screen reader or a braille display for reading it. And then furthermore, like cursor and selection information, which can be useful for moving, knowing where the focus is or where the text will be inserted when you insert it, and also the structure of tables. It's pretty important when reading a web page. In addition, the assistive technology might want to send basically what you could think of as actions to the browser. And these are things that, so oftentimes when you're using assistive technology, the other forms of input still apply. Like you can still, for instance, use the keyboard when you're using a screen reader, and keyboard interaction with the page is similar to how if the screen reader was turned off. So these things more often sit on top of normal interaction. And some of the things that can happen here are activating links or other interface elements, going through menus, selecting things, activating menu options, or selecting and unselecting them, changing the position of I said cursor, but I mean like the text cursor, moving the text cursor different places, and also selecting things, unselecting them, things that would be difficult to do if you didn't have like access to a mouse, for instance. Scrolling the browser window, or like making sure that elements are scrolled into view, another big thing. And here, maybe you're starting to see like why accessibility maybe can cause crashes that you otherwise wouldn't have, because you imagine that on the other side of this process boundary, you have handles on objects which in some way have DOM objects behind them. And this software can do everything an editor can do, everything the editing code in a web browser can do at any time. So like if there's like a dead node on the other side, maybe it's poking the node. And this is why like assistive technology stresses this part of the web platform in a way that like maybe developers aren't thinking of. So you start having to think about timing issues and dead objects and objects that have already been freed but not cleaned up, that kind of thing. Yeah. And finally, this is something specific to Chromium, but I just wanted to explain it because I think it's interesting to explain the next section, which are events that can be triggered from the browser that touch the assistive technology. So essentially the way this works in Chromium is the page changes, and you had an old accessibility tree and a new one. What Chromium does is it takes the two trees, it compares them, and from that comparison, it says like, oh, like, your children changed, or you're the same node, but, you have different text now. And from that comparison, it generates events. The content of my text changed. My children changed. My position moved, that kind of stuff. And then those events are sent to the platform APIs. And I mean, some of the things are, I said some, but other ones are, the focus, a different node is focused. A different window is activated. Some of these don't necessarily come from the tree comparison, but come from outside. So it's kind of a combination. and parent and children change, the properties of the node change, this kind of things. And these all are sent as signals to the assistive technology. So anyway, that's basically a really basic, quick intro to platform accessibility. And just to finish up, to go quickly over what we're doing, if anyone's interested in the Linux desktop side of this, is that we're implementing this for Chromium and ATK. Traditionally on the Linux desktop, Chromium used a software called Chromevox, which is what I understand, a very nice screen reader, but it's different from the native screen reader that people might be used to when using the Linux desktop. So this adds a deeper set of native interaction. And essentially the work involves connecting a lot of the pre-existing Chromium code to these platform APIs. And to go into some of these nitty-gritty details of Linux platform APIs, there are at least two pieces. One piece is the library called ATK, which is the sits on the web browser side. We kind of, in reverse of the naming conventions, the client application is called a server because it's serving its accessibility tree to a client, which is the assistive technology. And then sitting on the client side, so for instance, with a screen reader, is ATSBI2. These have like a mirrored interface that are almost exactly the same, but not quite. And then finally, one piece is mapping the accessibility roles inside the web browser to the set of platform accessibility roles, which are not one-to-one. So basically a cross-platform set of roles to a set of platform-specific roles. And this is actually specified. There's a spec, if you click on it, that lists for the major screen readers what, for instance, an ARIA role is on the platform and like how it should behave. Which is, I feel like, much deeper than most specifications go on platform-specific behavior. So, yeah, finally, this is almost done. I mean, we're finishing up some of the bugs now, so this should be active in an upcoming Chromium release. Probably not the next one, but maybe the one or the one after that. Okay. That's it for me. If anyone has any questions, I can try to answer them. So it's good.
The situation before was that it was not working at all?
You could use Chromevox to have a screen reader for Chromium, but my understanding is it didn't work with later versions of Chrome, or there was some issue where it wasn't quite exactly how it should be. So this is a better experience for Linux users, Linux desktop users. Yeah.
Out of curiosity, does the Chromium accessibility tree map, like, is it completely a transformation of the layout tree, or does it also account for other DOM bits?
It's different in at least one way. I'm sure there's more. Pseudo content has its own accessibility node.
Like, that appears on the layout tree.
Does it? Do they have their own? Okay.
I was thinking more about stuff like display contents, that kind of thing that doesn't generate layout boxes, but do.
I'm not sure about display contents. Yeah, that's a new CSS feature, right?
Newish.
Nearly implemented.
Yeah, well, I mean, a couple of years ago.
Okay.
Because it used to be synchrony, like Firefox shifted since 37. Maybe.
Okay. I have to go in and just look at how that works.
Should be the result.
What do you mean?
Like, it should expose the results if it happens.
What do you mean with the result? The result of what?
So you're talking about how like display contents doesn't actually draw the box and how
I
they
mean, there's no box. It's not like they don't draw. There's no box.
Okay, but since we're calling like the box tree,
It's not
what you would think would be
there's nothing there.
that's exactly what I'm saying. I don't know what you're gonna say.
Okay.
Right. So the connection should be there.
Right, but my point is that display contents may still have some semantic.
Yeah, that element needs to be in the accessibility tree, even though it's not in the box tree. That's a major bug, and it's
Oh, okay. I didn't.
it's been a major problem for people trying to navigate sites that use display contents.
Right.
It's the fact that it is not in the accessibility tree.
Is that it?
What?
Sorry.
And I think it's been partially fixed or fully fixed in several browsers, but I'm not sure.
It was fixed.
Yeah,
I
I know.
They get the results, but I don't know.
Yeah, I know. That was the question. I don't know.
Like,
It's okay. Yeah, yes, sir. I have one too.
I mean, I don't know the answer, but I can say that these sort of bits of CSS do cause major issues for accessibility technologies. For instance, pseudo content is a huge issue. The behavior is really inconsistent because it does show up. I mean, you have issues like it does show up in the accessibility tree, but when you select it, it doesn't show up in the visual selection or in the copy paste, but it does show up in the selected text as far as the accessibility tree is concerned. So like, essentially, it's probably fine as long as the author is not doing anything too weird, but the author could easily break.
Generated content it should be highlighted and it should be showing up in copy paste
But it's not selectable anyway.
But I know, but that.
Right, yeah. So basically it's like the implementation is like in a weird, different state. And
So that's an example of like where you want to see information from the box tree that's not in the element tree. And then we have other cases where you want information from the element tree that's not in the box tree. And so like depending on what exactly you're doing and what you're looking at, it varies a little bit.
And did you figure out the reference to the classroom was?
No.
Okay.
I mean, I have my opinion.
yeah. So all that to say that like places where some cans have been kicked down the road in CSS, like they become very important, like very pertinent for accessibility implementations pretty quick. So, but yeah, hopefully you're not writing novels in CSS content.
I think another issue is that some of the limitations you use table display, and it feels like table display. Like this, you can't navigate a table that's been displayed to something else as a table. That even like if somebody's transformed that information just for layout purposes to like a grid, for example, then you lose the ability to navigate the table as a table from an accessibility perspective. That's not good either. So.
Yeah. Cool. So. No. I mean, it's a really kind of painful. As an implementer, just doing plumbing, it comes up. Any other questions? Great. Well, thank you very much.